Welcome to the deep dive. Today we're opening up the maintenance logs, really zeroing in on an appliance that, well, it often gets ignored, right up until it breaks down.
Yeah, the commercial ice machine.
Exactly. And our mission here is to look at sources suggesting some quick, high-impact ways to cut energy use in commercial spots, focusing specifically on what some insiders call the sneaky energy hog.
Sneaky is a good word for it.
We're not talking about the big obvious things today, like, the walk-in freezers or the huge ovens. Nope, we're focusing on that machine probably humming away in a corner somewhere making ice. But it could be quietly adding, maybe an extra $200, even $400 a year to the electricity bill.
That's right. And it's not just about how long it runs. It's about inefficiency, resistance, really.
Okay, resistance. Let's unpack that. Why is that resistance costing so much?
Well, what's really interesting is that this resistance, it's physical and totally predictable, actually. Comes down to mineral deposits from the water, scale,
Right, hard water issues.
Exactly. Most folks just see these machines as plug-and-play passive things. But they're constantly working with water, evaporating or freezing it. And that process, it concentrates minerals right onto the important parts inside.
The heat exchange surfaces, you mean?
Precisely. And the problem isn't just the scale being there, it's the thermal resistance it creates. Imagine trying to freeze water, but first, the cold has to get through, say, a layer of chalk.
Okay, I can picture that, like an insulation layer.
That's basically what it is. That chalky stuff is an insulator. It stops the cold refrigerant gas in the evaporator plates from efficiently pulling heat out of the water.
That chalk layer analogy really clicks, but let's get into the mechanics. What actually happens inside when that insulator, that scale, builds up? How does that turn into higher costs beyond just, taking longer to make ice?
Oh, it creates a whole cascade of problems. Inefficiency built on itself. First off, just to get the water cold enough to freeze, the compressor has to work way harder and run for much longer cycles.
So higher electricity draw right there.
Definitely. Higher amperage. And second, this is crucial for actually getting ice. The machine might struggle with its harvest cycle.
How so?
Well, scale can gum up the thermal sensors, the things that tell the machine, okay, the ice is ready, drop it now. If that harvest fails, or even just stalls, the whole freezing cycle might just repeat, needlessly, burning energy.
Wow. And I guess we can't ignore the heat either, if that compressor is working harder and running longer.
It's dumping more heat out, absolutely.
So if your ice machine is sitting in an already hot kitchen,
You're making your air conditioning system work overtime just to fight the heat coming off the struggling ice machine.
it's like a double hit on the utility bill. Energy for the inefficient ice machine and energy for the AC folding it.
Exactly right. And if you look at the bigger picture, that operational inefficiency, it translates directly into mechanical strain. Longer run times, higher pressures inside, that puts extra wear and tear on expensive parts. Your compressor, the water pump, those little metering valves.
So that's why operators sometimes see these machines failing way earlier than they should.
It's often a big factor, yes.
Yeah.
The machine just wasn't built to constantly battle against that layer of insulation, that thermal resistance.
The sources we looked at called this a silent drain, but I kind of want to push back on that a little. I mean, if a machine totally fails because of scale, that's usually a very loud problem, financially speaking, isn't it?
That's a fair point. Loud and sudden when it finally gives up.
So how do we spot this earlier, before the whole thing needs a costly repair?
Okay, good question. It's silent, mostly because it still makes some ice, right? So the waste isn't immediately obvious. To catch it early, you need to watch for two main things: cycle time creep and noise.
Cycle time creep.
Yeah. If the machine used to make a batch of ice in, say, 20 minutes, and now it's consistently taking 30 minutes, that's creep. And scale is almost always the reason. The extra noise comes from that compressor being really stressed, running near its maximum safe pressure.
Okay, that makes sense. Listen for the strain, watch the clock. Now, the good news, based on the research, is that fixing this doesn't actually require, heroic effort. The sources frame these solutions as the 5-minute fix, which sounds pretty manageable. It emphasizes being proactive, these low-effort routines. So let's get specific about this weekly check-in. What are we actually doing?
Consistency really is the name of the game here. The recommended weekly routine, it's all about prevention and just looking. This 5-minute fix, it's not about getting out harsh chemicals every week, no. It's about basic hygiene and stopping minerals from getting that first grip.
Okay, so what are the steps?
The main things are, first, just a quick visual check of the evaporator plate. That's the metal part where the ice forms. Look for any white haze, especially where the water flows over it. Second, wipe down the inside of the storage bin and, importantly, the water reservoir.
Why the reservoir specifically?
Ah, because that's usually where the water level float sensor lives. If that sensor gets coated in scale, it can give bad readings, and that can totally mess up the whole fill and freeze cycle timing.
Got it. Target the float sensor too. That's a great practical tip. But, thinking about a busy kitchen, what's the biggest hurdle to actually doing this weekly check?
Time, right. It's always time.
Yeah, we'll get to it later syndrome. How do the sources suggest overcoming that?
The strongest recommendation is to basically hack your habits. Tie the ice machine check to something else that has to get done regularly.
Ah, like piggybacking tasks.
Exactly. Maybe make it part of cleaning the fryers every Sunday.
Hmm.
Or do it first thing on the main delivery day morning. Anchor it to an existing non-negotiable task. That helps build the routine.
Okay, that makes sense. Attach it to something solid. Now let's talk about the next step. The quick wipe is preventative, fine. But what if we do see that white, chalky stuff starting to build up? We need to do more, right?
Yes, if you see actual scale, that chalky deposit, you need to descale. That's different from the quick wipe.
And that involves...
It does. Descaling needs a special acidic cleaner. Often it's something like a nickel-safe phosphoric acid blend. It's designed specifically to dissolve those calcium and magnesium minerals. That's usually more like a quarterly job, maybe more often if you have really hard water. You run this solution through the machine using its clean cycle setting.
Okay, so descaling handles the minerals. What about sanitizing? Is that the same thing?
No, completely different. And the order matters. Sanitizing is about killing biological stuff. Mold, bacteria, slime. That usually uses a different solution, like a specific sanitizer or sometimes a diluted bleach solution, following manufacturer guidelines, of course. And crucially, you always sanitize after you descale.
Ah, why after?
Because the scale itself, those mineral deposits, they create little rough patches and crevices. Bacteria and mold love to hide in there. If you try to sanitize first, the sanitizers can't properly reach the stuff hiding in the scale. You've got to remove the mineral shield first, then kill what's left.
That's a vital distinction. Remove the physical barrier, then deal with the biologicals.
Okay, and speaking of biologicals, that brings up another point you mentioned earlier about efficiency dealing with old ice that's just sitting there melting in the bin. Why does that make the machine work harder?
Well, think about the energy involved. The machine uses energy, BTUs, to turn water into ice at 32 degrees Fahrenheit, right?
Right.
If that finished ice just sits in the bin, melts back into water, and then the machine kicks on for the next cycle, it's not just freezing the new water coming in, it's also having to refreeze the water that had already spent energy freezing once.
Ah, so it's wasted effort.
Right.
Recycling the same cooling job.
Exactly. You're basically paying to remove the same BTUs over and over again.
Yeah.
So, yeah, you need to use the ice, rotate stock, and discard old, excessively melted ice periodically. Don't let it just sit there turning back into water. The machine has to freeze again. Okay, this is all making sense, but here's where it gets really concrete, I think. The proof. It's one thing to talk theory, but the sources had a really specific, tangible story. An anecdote that shows the payoff for doing this cleaning.
Yes, the jet engine case.
That's the one. They described this restaurant, and their ice machine literally sounded like a jet engine. Apparently, it was just running constantly, really long stress cycles, struggling to finish, struggling to drop the ice.
Yeah, that jet engine sound. That's a dead giveaway. It screams high pressure.
Meaning
Meaning the compressor is working incredibly hard, likely pushing against its high-pressure safety limit. The issue probably wasn't the condenser coils on the outside, but the evaporator plate inside the freezing surface. It was likely so caked in scale that heat just couldn't transfer effectively. The compressor couldn't get rid of the heat it needed to, just to make the water change state into ice.
Okay, so they identified the problem, massive scale buildup, and then they actually cleaned it, right? Took it offline, did a proper descaling. The source said it only took about, 30 minutes of actual labor?
Roughly, yeah. Not a huge time investment for a professional.
And what happened immediately after? What were the results they could actually measure?
Well, the turnaround was apparently instant and pretty dramatic. First thing they noticed was the noise dropped significantly. That tells you the internal pressure went way down. But more quantifiably, the cycle time.
The time to make one batch of ice.
Exactly.
Right.
That immediately dropped by 40%. 40.
Wow, nearly cut in half.
Essentially, yes. It slashed the machine's runtime per batch almost in half. Huge efficiency gain right there.
And did that show up on the power bill?
It did. They looked at the meter readings before and after the cleaning, and they found a drop of about $30 per month, just from that one machine running efficiently again.
$30 a month. Now, that might not sound like a fortune initially.
But annualize it. That's $360 saved per year.
From a half-hour cleaning session, that's a crazy return on investment, isn't it? Like 720% if you factor in maybe $50 for the labor.
Easily. And remember, it's not just saving on the electricity bill, the operating cost. It's also preventing that much bigger capital expense down the road by saving the compressor from burning itself out.
Right, preserving the life of the machine itself. Okay, so let's boil this down. What's the big takeaway here for anyone listening?
I think it's that real efficiency, significant savings, often isn't about giant, expensive upgrades. It's hidden in these small, consistent maintenance actions. That 5-minute weekly wipe down, getting that quarterly descaling done on time, it adds up big time.
It dramatically cuts running costs, extends the machine's life, and makes sure you actually have the ice you need when you need it. Cleaner ice, too.
Absolutely. So if we're talking practical steps, connecting this back to everyone listening, here's your action item for this week. Go take a look at your ice machine. Seriously. Check the waterline area. Peek inside at that evaporator plate if you can safely see it. Look for that white chalky stuff.
And listen.
And listen. Listen to the compressor. If you hear it running constantly or making that high-pitched whine, that jet engine sound we talked about, don't wait. Get that cleaning scheduled. Call a service tech if you need to, because the cost of putting it off, it's showing up directly on your next utility bill. Guaranteed.
That's fantastic practical advice. And, it perfectly sets up our final thought for today, which really stems from what we've just discussed. If something as seemingly simple, as routine, as scale buildup on an ice machine can waste hundreds of dollars and potentially wreck expensive equipment, where else are we just, burning cash because of neglected routines?
Good question. Other sneaky drains.
Exactly. And the source material actually hints at where we might look next. Timing waste, particularly on the cook line. Think about fryers, griddles, ovens. Are you firing them up, burning gas or electricity for a full hour before the first customer even walks in, turning things on way too early?
Yeah.
You're literally evaporating money before you make a single sale.
That hidden cost of excessive warm-up time.
Yeah.
That could be significant.
That's definitely something worth digging into. And that's exactly what we'll unpack in our next deep dive. Thanks for diving deep with us today.